Welcome everybody to the OWASP Boston chapter meeting for September, and this is going to be our last one for the year because we have LastCon next month and then the holidays, so we'll be picking this up again in January, which we hope they're going to have the crypto party again, right Josh? Yes. This meeting sponsored for food by LastCon, so the income we get from LastCon helps to fund our budget for the following year, so to help pay for the food. And the venue, of course, National Instruments. I'm Tiana Chandler, the chapter leader, and I have listed up here other folks that are on our leadership coordinators and advisory board members. So if you have any questions about the chapter, those that are on coordinators on the leadership team, raise your hand, please. So if you see people around here, if you have any questions, just come to ask one of us. For this meeting is eligible for a 1-hour CPE, and the way I'm working on it right now is that if you just please email me directly, I can send you a certificate to have so that you can have that. These meetings, as well as other resources with OWASP, is free and open. You do not have to be a member. However, well, I'm getting ahead of myself. First of all, just to show support, there's several ways you can do that. Volunteer opportunities, getting involved with the leadership, speaker opportunities like speaking at one of these events and other local events we may have. Shopping on Amazon, you can put in for OWASP at smile.amazon.com. And on to the membership part of it, as I mentioned, you do not have to be a member, but we do have membership levels available to show your support. Griff over here, he's our membership coordinator, so if you have any questions about that, please talk to him. These meetings and other events we may have, I send out through our OWASP Austin mailing list. It's a Google group. You do not have to have a Gmail account to be on the list. You can go to austin.owasp.org to sign up for that so that you can be informed of when we have certain events. We have a weekly study group that also meets here at National Instruments in a different building. Currently, they're working on the LastCon badge game. Matt Pardo is our education coordinator. I think Matt's right over there. And I think they're wrapping up soon. Yes. Okay, are we going to continue that through the rest of the year, or are we just going to stop and then, okay. Yeah, and so the information for the study group should be on the austin.owasp.org as well, but there's also a Slack channel, Austin OWASP, in which most of this is being communicated, the status and such. So the main thing coming up next month is LastCon. It's our 10th year anniversary. We have our keynotes lined up. Conference tickets are still available. One thing I took off of here, but I meant to say is we still have some discount tickets available for 10% off, and the discount code is OWASP Austin, all one word. And so if you haven't signed up and you're wanting to attend, then you could do that. We have our conference schedule already set. I'm sorry, hold on a second.
I just want to mention the discount codes expire the last day of this month, so be sure and do it before then and not after then. Also, the top 10 training on Wednesday, which is free. If you have any interest in the OWASP Top 10 and you want to learn more about it, it's free on Wednesday. That class is filling up, so if you're interested, please sign up for that soon.
Yes, thanks for that clarification. And I have a few more slides here I added for our training. So we do have pre-conference training. I just wanted to highlight these. There's 2-day training classes doing DevSecOps with OWASP projects, cramming it all in, fundamentals of comprehensive web application testing, and attacking Android and iOS apps by example. You can find out more information about that on our lastcon.org site. We still have a few spaces available, so if you're interested in training, The pricing is very well, if you compare it to other conferences, it's a great price for the quality of training that you can get. We also have one-day training, effective security leader training, a business-driven approach to practical management technique. And then we also have a threat modeling workshop, which is being offered free. So again, those are on the lastcon.org that you can register for those. Just a placeholder here, upcoming chapter events. We do have just a placeholder, like I said, for potential doing training other than at LastCon. Still looking at possibilities, so stay tuned for that. And our Office of Security Professionals Happy Hour would start up again next year in January, and hopefully we'll have a better organization on how to get our sponsors and have those on a monthly basis there. Other events locally, just have some of them listed here, mostly from the ISSA calendar. You know if anybody else had any events that they know of, I should mention to the group. Okay. Also, like to take this moment for if there's anyone working at a company that has job openings that they want to mention.
So we have a couple of open positions for joining the application security team at Oracle. So if you're interested, just let me know after the conference.
We have some technical account management. At Rapid7, we have some technical account management positions and pen testing roles, as well as some roles in our SOC. So if you're interested in a blue team or red team, just ping me right after the meeting.
Hey, I'm Mike. I run product security for DigitalOcean. We have a senior product security engineer opening. Just got it open. Would love to have someone badass. We're growing our team pretty rapidly this year and next. Thanks.
Mark Spears, Solid Security. We're an Austin-based IR and MSSP firm. We have opening for someone in our MSSP department for managed security services. If you're interested, we're looking for more of a junior, even entry-level person. We can kind of grow organically with our group. So.
Anybody else? Okay. And so now I'd like to introduce PAC Foley to talk about OAuth 2.0 Misimplementation, Vulnerabilities, and Best Practices.
Hi, how's it going, everyone? It's quite the turnout. Looks like people are pretty excited about OAuth here. Yeah, so my name is PAC Foley, and I'm a security engineer at Procore Technologies. I have to preface by saying I've only been a security engineer for going on 4 months now. However, so I want to say, don't ask me any questions about security other than OAuth. So I started out in identity and access management, and I spent the majority of my time seeking out and mitigating vulnerabilities due to, the majority of the time, misimplementations of OAuth. That tends to be the normal place where you find vulnerabilities. However, there have been many CVEs opened against libraries and whatnot, and those have also required mitigation as well. So if anyone read my abstract, I do say the word scopes in there, but I want to say that this talk is not going to be at all about OAuth scopes. I was talking about scoped interactions that are scoped particularly to the resource owner and the kind of client that we're using. So yeah, so not OAuth scopes, which OAuth scopes, in case you didn't know, they scope down the amount of access that an application has to a protected resource. All right, so let's get going. So what is OAuth 2? OAuth 2 is an authorization framework. It enables third-party applications to obtain temporary limited access to a protected resource on behalf of a resource owner. OAuth 2 doesn't define user authentication at all. It instead defines how to safely delegate authentication. OAuth 2 does, though, define client authentication. So yeah, a lot of people think it doesn't define authentication at all. It definitely defines application or client authentication. What defines the OAuth 2 framework? So the OAuth 2 framework is defined by 4 authorization interactions. Each one of these are scoped, there's that word again, to the type of client obtaining authorization and the type of resource owner. Resource owners could be either a user, an end user, or a client. The 4 grant types are the authorization code grant, the implicit grant, and the client credentials grant, and the dirty little one right there is the resource owner password credentials grant. That one I'll talk about a little bit, but I'll spoil it for you. That one is no longer recommended at all. If you think about it, you know, we're talking about third-party applications. We don't want to give them access to the resource owner's credentials. So in OAuth, in the RFCs, these interactions are defined between 4 different roles. Now those roles are the resource owner, which is an entity capable of granting access to a protected resource. The resource server, which is the server hosting the protected resources. And the client, which is an application making requests to the authorization server, or to the resource server on behalf of the resource owner. A client can be either a web application, a user agent-based application like JavaScript running in a browser, or a native application, such as like a desktop application or a mobile application. The authorization server is the server that handles user authentication, and that is not defined how it handles it, but it handles it. And it also is the server that gives tokens to the client. All right. So OAuth is confusing. There's quite a bit of documentation to go through, and when it comes to best practices, I've tried to narrow down the most important terminology in OAuth, and I've found the most important terminology are these four terms. So the confidential client. A confidential client is a client that can guard its credentials. Web apps are the only kind of confidential client. So that is a client that is making server-side, server-to-server requests and passing its credentials in order to authenticate. A public client is all of the other kinds of clients. It's a client that cannot keep its secret credentials confidential. So native apps and user agent-based apps are all public clients. So we said OAuth doesn't define user authentication. However, I do believe that user authentication is very important in OAuth. User authentication is a user proving that they are who they claim they are. And then there's, of course, client authentication. Client authentication is verifying that a client is who they say they are. OAuth essentially has all of these interactions defined between each kind of client in each kind of resource owner. And in the case of a public client, you can imagine if it can't keep its credentials safe, then there's no way for it to authenticate. There's absolutely no way that a public client can prove they are who they say they are. In OAuth, you do see attempts at this, ways of mitigating a lot of factors, but a public client can never be fully trusted. So the flows. These are the flows as defined from the 2012 RFC for OAuth 2.0. I've tried to lay them out in a really simplistic way so you can choose your grant type based on a couple things. What kind of resource owner do we have? Is it a user? Is it an end user? Or is it an application? Is it a client? And what also matters is the client type. Is it confidential or is it public? So you can imagine that for a if the resource owner is a user and it's a public client, it's going to be different than if the resource owner is a user and you have a confidential client, because you can have an extra step in being sure that the client is who they say they are. And you can also see the not viable section. You can't have a client who is a resource owner and it be a public application because there's no way for the client to authenticate. So we'll talk about the first one, the easiest of all of the flows and the one with the least amount of problems, and that's client credentials. So in this case, your resource owner is an application, is a client, and it has to be a confidential client because the whole point is the only one that can authenticate is the client. So this is the application owns the protected resource. And so all it has to do is pass its client identifier and its client secret to the authorization server, and it can receive a token and access the stuff that it owns. It's the simplest one. The next one is the authorization code grant. The authorization code grant is the most complicated of the flows, and that's because your resource owner is a user and your client is confidential. That means both your resource owner and your application can authenticate. And so the flow goes like this. We start from A, the client. So this is a server-side web application. And it's going to redirect, to send a 302 redirect to the user agent. And the redirect is going to go through. It's going to redirect to the authorization endpoint of the authorization server, passing its client ID and the client's registered redirect URI. Once you hit the authorization server, the user can then authenticate. Typically, the authorization server is going to respond with a form. The user can then enter their credentials via the browser. And then once the user authenticates, the authorization server then passes back an authorization code to the redirect URI. So it's another 302. Now, the authorization code, what that states, oh, I guess I missed something. So after the user authenticates, typically another form is rendered where a user then has to grant access to the application who wants to gain authorization. So the authorization code is proof that the user both authenticated and granted access to the client. So in this redirect, you can see it is possible to intercept that authorization code, right? So just keep that in your mind. It's definitely possible. You could set up a proxy server. You could intercept the authorization code, whatever. The user had to have authenticated. Maybe it's not a big deal, but we'll talk about that. So then the client side has the authorization code. It can pass back the authorization code, its registered redirect URI, and its credentials, its client ID and secret associated with the application. And so that's when client authentication happens. So now we know the user is who they say they are, the application is who they say they are, the user granted access. Now we can pass back a token with an optional refresh token. And keep the refresh token in mind. In OAuth, in order to refresh a token, the client has to authenticate again. It's based on a form of trust between the authorization server and the client. All right, so the next one is the implicit flow. So the implicit flow was built for public applications. In this case, the resource owner is the user, client is public. It looks a lot like the authorization code flow, except it's missing that whole passing of the authorization code back. The reason why is because the client can't then pass it back and prove it is who it says they are. So what ends up happening is that after the user authenticates, it redirects with the access token in the URL, and then that can get parsed out and the client can grab that. So inherently, this flow is less secure than the authorization code flow because we don't know who the client is. It's implicitly, authorization is implicitly given that the user has authenticated. Resource owner password credentials. I already said I wasn't going to talk about this. And all of the new drafts for security best practices and whatnot have said that the resource owner password credentials must not be used. And in the initial RFC, they said that this should really only be used to get people to start using OAuth and start using tokens rather than passing a username and password directly to an endpoint or whatever. But yeah, this should no longer be used. If you're currently using it, try to transfer onto the authorization code flow if you can. Common misimplementation. So I've seen this time and time again. Public clients, such as native applications, implementing the authorization code flow for the purpose of obtaining refresh tokens. So public clients, native applications, mobile applications, they want refresh tokens because they don't want to force the user to log in every time an access token expires, right? And that's understandable. From a user perspective, you don't want that to happen. And what ends up happening is that when people implemented the implicit flow, is that they would increase the amount of time that the token would expire, and so it would give more time for access token leakage and replay attacks and all of these things. But essentially, when you implement the authorization code flow for a public client, it opens up a vulnerability where the client credentials can be intercepted. And it looks a little bit like this. So for a browser-based application, now you no longer have the server-side client making server-side requests, right? And so now you have JavaScript just running in a browser. Essentially, you're going to start off up here. You're going to redirect to redirect URI. User authenticates. They grant authorization. Authorization code is passed back, right? And then the user agent now has to make a request, but it needs to authenticate. And so, folks start either hard coding it or getting the secret passed to them at some point. And either way, at some point, they're going to have to send a request from the client, the public client, to the authorization server, and that can be easily intercepted because it happens from the device. And so therefore, you can get the client secret. And then if other flows haven't been restricted with the client ID and secret, you remember the client credentials flow, right? All the client has to do is if they register their application, a third-party app with the authorization server, then they can just start making requests with another app's client ID and secret. All right, and then for native clients, implementing the authorization code flow, someone could just stick, if you could get a malicious app onto the device, what happens is the malicious app can register the legitimate app's redirect URI with the OS, and what happens is the legitimate app makes the auth request, right? and the user then authenticates, and then the authorization code is sent back, but it's then sent back to both malicious app and legitimate app. And now, malicious app has the authorization code, and it can now make a request for a token and get the token. And so this would be, of course, barring the fact that you would need the client ID and secret. So there have been many libraries that have been created for public clients to use authorization code and just not pass the secret. All right, other common misimplementations. So confidential clients implementing the implicit flow simply because it's easier to implement. I've heard this one mainly from outside developers who are trying to integrate with a system. And it's a simpler flow to implement. You don't have to deal with refresh tokens. You only have to deal with one request. You make one request, you get a token back, all is good. Maybe they don't care that their access token is going to expire or whatever. But you know, that one, it opens up unnecessary risk of access token leakage and replay attacks. So yeah, current best practices. So in light of the two former issues and many other issues that exist, a new flow has been created for public clients. It was initially created as a way for native applications to use the authorization code flow safely so that they could get refresh tokens. And so this one's called ProofKey for code exchange. The way this works is that this is a very simplified diagram. I apologize, I should have made a better one. But the way this one works is in the initial authorization request, a code verifier, which is an alphanumeric string with sufficient entropy to not require a salt or anything, is transformed with a one-way hash, and then it's sent over in the authorization request. The authorization request requires the client ID and the registered redirect URI, as well as with PKCE, the code verifier. So the user then authenticates at the authorization server, and after successful authentication, hopefully, the code verifier, the transformed code verifier is then stored, hopefully also tied to the authorization code. The authorization code is then sent back, and then on the access token request, when the client ID and secret is passed, or sorry, this one is for native applications, there is no secret pass. In the token request, the code verifier is then sent in its non-transformed version. The authorization server then has the transform method. It hashes the code verifier, and it sees that it matches the previous one. So what you notice is that when the authorization code was sent back, it can't be intercepted and then replayed because they would need to know what the transformed code verifier looked like. So this essentially, it gets rid of the native application interception attack that we had showed on the previous slide here. So new specs. Okay. So for web apps, confidential clients, although PKCE has so far been recommended as a mechanism to protect native apps, this advice also applies to all kinds of OAuth clients, including web applications. So in the case of even a confidential client that can authenticate, it still guards from its authorization code from being intercepted. That will guard against replay attacks in case the client ID and secret had been leaked. And now they're saying clients using authorization grant, anyone using the authorization code grant must use PKCE. For public clients, there's no reason to use the implicit flow anymore. Clients should not use the implicit grant or any other response type issuing access tokens in the authorization response. Clients should instead use the response type code as specified in section blah, 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 which this one was referring in particular to the previous comment of all applications using authorization code should use PKCE. And so the new flows, it looks like this. It's way simplified. It looks a lot better now. We don't have all of the clutter deciding whether or not you should use resource owner password credentials. The flow is the same for confidential and public if the resource owner is a user. You just don't pass the secret here. So you still can't magically authenticate a public application. That just can't happen. However, we can guard the application from the interception vulnerability. Remaining vulnerabilities. So we just showed that PKCE addresses the interception of the authorization code in public clients, and it prevents authorization code replay attacks in confidential clients. Unfortunately, PKCE does not prevent, and this is a little complicated, it does not prevent a malicious application from initiating the authorization request, then intercepting another application's authorization code and submitting its code verifier with the stolen authorization code. And this is what that would look like. It's very complicated. So you have, again, it's a lot like you have two native applications. You have a malicious native application and a legitimate application. These are both on the same device. Malicious application has registered legitimate application's redirect URI with the OS. So what happens is the authorization code request, they pass the transformed code verifier with legitimate app's redirect URI and client ID. The authorization request then goes to the authorization server, and then the malicious app just halts. It's like, I'm just going to wait now. Legitimate app now then sends an authorization request so it's a redirect. So it sends it to the OS, it redirects to the authorization server. The user authenticates via legitimate app, and after authentication, the authorization code redirect happens, and then the authorization code is then sent both to malicious app and to legitimate app. Now, where are we at? So now malicious app can submit legitimate app's authorization code with its own code verifier to the authorization server and receive an access token. Now this is a very complicated flow, and it's very unlikely for it to be implemented and actually work because there are some simple mitigations that can be implemented to avoid this. However, it's by the definition of PKCE, this is possible. So yeah, I guess some notable mentions. There is a caveat. So I said that the new best practices say don't use the implicit grant, you should use authorization code. But they do add a may, that you may use the implicit grant if the issued tokens are sender constrained and the access token, and access token injection and the authorization response is prevented. This isn't well defined how to do this, but people have done it and they've come up with solutions. And also, if you have implicit, if you're using the implicit flow, it's not 100% necessary to just immediately jump to PKCE. It may be that you have safely implemented the implicit flow. It's very easy to misimplement it. And using authorization code with PKCE really just, it makes it a lot easier to not do the wrong thing. With regard to PKCE for any client, there is also in OpenID Connect, they have the nonce parameter, which essentially does, it's done differently, but it will achieve the same thing that the code verifier does in PKCE. However, they use like a session cookie or something like that in order to store it on the client side. Now OAuth is changing rapidly. I haven't seen papers come out so fast with anything else, and things change so fast it's hard to keep up with. But at least with PKCE, A lot of these misimplementations can be pretty easily fixed, especially if it's a native app that implemented an authorization code flow. All you have to do is add another parameter in the request, and now all of these vulnerabilities have been mitigated. And so that's about it. Here's some references. And does anyone have any questions?
Question?
Exciting world of OAuth.
Okay, hold on.
So you have this new standard. What's the expectation in terms of when service providers, whether they're on the client side or the resource side, will have to be compliant? Is there sort of a timeline for that?
It depends on what kind of compliance you're talking about. Best practices are just recommendations, and the big providers like AWS, Auth 0, they're all on top of it. They've already fixed things up, and it's really on the application who's trying to gain authorization via the authorization server. It's their job to sort of fix it to use those new tools. But as far as I know, they haven't. None of the libraries or the providers have like gotten rid of implicit flow. Like that's still around. It's just not recommended for any new applications to implement it. But like I said, you don't need to jump right away to PKCE if you have a safe implementation of implicit. It's a good place to go on your roadmap, and especially if you're not sure about it. OAuth can be complicated. I know many developers who, the second you hear OAuth, they go running in the opposite direction. So I'm really happy, actually, this many people showed up to this.
I have another one, if there's another question. So one of the challenges that we've had kind of implementing it is on the client side, you sort of assume either a mobile client or a web app. But nowadays, web apps are rich web apps. So they have JavaScript, and actually the JavaScript is what's doing the work on the browser, which is on the client and the end user's computer, and then interfacing to microservices and containers on the back end that are not all singular, right? Like a lot of these protocols were designed where a server was singular entity, and now it's actually multiple spread out nodes. How do you best implement that in that manner and make sure you're authorizing the right service and not something that's in the middle?
Right, yeah, totally. So I've seen lots of OAuth JavaScript libraries being used that the JavaScript was served up from a server, right? If you have a server, it can handle if you have a web server, it can handle all of the OAuth interactions and then pass the token back up to the client. That shouldn't be a problem. The problem is having from the client side going through these OAuth interactions. If you have a server, it should be completely possible to implement authorization code with PKCE and client authentication and have no issues.
Anybody else?
Is it possible to get a copy of the slide deck?
Copy of the slide deck?
Yes.
Yeah, absolutely. Email me. I didn't put my email up.
Okay, thank you.
Okay, they'll be posted on the Vimeo feed. And you can find it if you look at the Austin chapter webpage.
Perfect, thank you.
All right. Well, thanks, everyone.